Hello, and welcome to Summarize Science. The James Webb Space Telescope is giving us incredible new views of the cosmos, but one of the biggest challenges is studying exoplanets. These distant worlds are incredibly faint next to their brilliant host stars. Trying to analyze a planet's atmosphere is tough because the star's light completely overwhelms it. Traditionally, scientists use computer models of the star to subtract its light, but as this graph shows, even the best models have small errors. These errors are often much larger than the tiny signal from the planet itself, hiding it from view. So, in a new study, researchers tried a brilliantly simple and effective trick to study the exoplanet WASP-17b. Instead of using a model of the star, they used an actual observation. They pointed JWST at the system right when the planet was in eclipse, completely hidden behind the star. This gave them a perfect, clean spectrum of just the star's light. They could then subtract this real starlight from observations taken just before the transit, when the planet's unlit Nightside was facing us. The result is the first-ever JWST emission spectrum of WASP-17b's Nightside, seen here in blue and cyan. This is a huge deal, as it proves this new technique works beautifully. So, what did they find in this hidden atmosphere? The data suggests the Nightside has a temperature of around 1000 Kelvin, which is incredibly hot, but much cooler than its dayside. This large temperature difference means heat isn't transported very efficiently around the planet. The analysis also revealed the tentative presence of some interesting molecules, including methane and sulfur dioxide. The sulfur dioxide is particularly strange because it's likely created by intense sunlight on the dayside. Finding it on the Nightside suggests that powerful winds, moving at thousands of miles per hour, are dredging it up and whipping it around to the dark side before it can be destroyed. Furthermore, by comparing the day and night temperatures, the scientists could constrain some of the planet's fundamental properties. This diagram shows their findings suggest the planet has a bond albedo of around 0.42, meaning it reflects about 42% of the light that hits it. This implies the presence of reflective clouds, backing up findings from other recent studies of WASP-17b. So, let's recap the important points. Researchers have validated a powerful new method to study exoplanet atmospheres without relying on imperfect stellar models. They used it to get the first clear look at the chemistry of a hot Jupiter's Nightside, revealing a cooler-than-expected temperature and evidence of a violent, planet-wide weather system. This technique opens the door for JWST to characterize the atmospheres of many more exoplanets in the future, giving us a clearer picture of the incredible diversity of worlds beyond our solar system.